The lesson today is all about differentiation by first principles. While you may ask me what differentiation is, it will be clearer towards the end of the lesson. So by the end of the lesson, I would like you to be able to define a limit and apply a limit of 0 to the difference quotient to find the gradient of a function by first principle, and generalize the gradient function or derivative using the first principle process, and link the concept of a derivative to small change. Alright? Now, last lesson I show you the limiting chord process. You can find the gradient of a point of any function by using the limiting chord process. Alright? Either moving from here to the left or moving from the right until you can get the tangent. Now, let's have a look at this function here. I've defined point A and B. Alright? I want to find the average change between A and B. So the average rate of change of function from A to B is change in the vertical distance, which is here, the vertical distance, and the horizontal distance here. Correct? I'm going to introduce you to a new notation called the Leibnitz Notation. So the Leibniz notation states that delta y over delta z is equals to the incremental change in y over the incremental change in x. So delta here means incremental change. So that would be delta y, that would be delta x. Correct? So now we need to use the difference quotient notation. We know the coordinates of point A and point B, and we can now write delta y over delta z is f of x plus h, which is this point here. Take away fx. So delta y is f of x plus h minus f of x. And then from here to here, which is x plus h minus x, which is h. So therefore, delta y over delta x is actually function of x plus h minus function of x divided by h. Alright, what can we do with this? Let's go back and recap the average rate of change. So we can use the average rate of change, find the average rate of change between 2 points by using the gradient notation, or we can use the different quotient in Leibniz notation, which is this one over here. From here, I'm going to link it to the limiting chord process. But before that, let's think about looking for the difference quotient of a function. So if I've got a function of x squared minus x plus 2, how do we find the difference quotient? So we start off with fx, you know what fx is, and then what fx plus h is. So therefore, what you need to do is substitute x plus h as x. So therefore, you got x plus h squared minus x plus h plus 2. And the difference quotient will then be this bit, which is f of x plus h, take away f of x. Now, note that I will always use a bracket, especially when I've got expression with 3 or 4 terms, or 2 terms, so that I know the sign of, for example, x squared will be minus x here will become plus x. Alright? Expanding, we will have this, which is f x plus h minus fx. What we can do is eliminate x squared minus x squared equals to 0, minus x plus x, that's 0, plus 2 minus 2, that's 0. So therefore, we have got 2hx plus h squared minus h over h. Can we simplify this further? Of course you can. What you need to do is factorize the numerator, and therefore the difference quotient for this function is 2x plus h minus 1. Here I'm going to link this to the limiting chord process. So we know that we're getting closer and closer and closer and closer and closer, A and B. And therefore, we need to limit the chord, as in limit of h approach 0. So in this case, when I've got h approaching 0, 2x plus 0 plus minus 1 will become 2x minus 1. Alright? Keep that in mind. We'll come back to this a little bit later. Alright? Now here, what I want to show you is by using this notation, the Leibnitz notation, and finding the different quotient, we can actually find the derivative of a function. And note that the derivative of a function is actually a function as well. It's the gradient function. So the derivative is derived using the process of differentiation, which is calculating the difference in the variables. So what we're doing here is differentiation by first principles. I will teach you a slightly simpler method next lesson, but I want you to be able to do differentiation by first principle. Alright? So what we need to know is the Leibniz notation. Instead of limiting delta x approaching 0, delta y over delta x, we use dy dx, or we use a function notation, fx, and the derivative function is f dash x. Alright? Now, let's use the process of differentiation by first principle to show that the gradient function of y equals x squared is 2x. So let's start off with writing dy dx. The Leibniz notation equals to limit h approach 0, fx plus h minus f of x divided by h. Now, of course, x plus h, because it's x squared, we know that it's x plus h squared minus x squared. Expanding that, we've got x squared plus 2hx plus h squared minus x squared. Now we can eliminate the x squared, and therefore we have limit of h approaching 0, 2hx plus h squared over h. And of course, we could simplify it. Limit of h approaching 0 to x plus h by factorizing the numerator. And therefore, when h is 0, or when h approaches 0, the gradient function of y equals to x squared, dy dx is 2x. Alright? Let's try with the next. So here, dy dx equals to 2x. You can actually use this to find the gradient at any point for y equals to x squared. Now, what I'd like you to do is pause the video for a while and start using the first principle to actually work out the gradient function of y equals to x cubed plus x. Alright, so you know you need to find dy dx. We write limit h approach 0, x plus h cubed plus x plus h minus x cubed plus x over h. Alright, and here limit of h approach 0. Expanding it, I've got x cubed plus 3 x squared h plus 3 x h squared plus h cubed plus x plus h minus x cubed minus x over h. Of course, you can eliminate the x cubed, you can eliminate the x. Alright, so now we have limit of h approach 0, 3x squared h plus 3x h squared plus h cubed plus h over h. Now dividing every single term by h, we have limit of h approaching 0, 3x squared plus 3xh plus h cubed plus 1. And therefore, when h approaches 0, the gradient function of y equals x cubed plus x is 3x squared plus 1. Now, the next example, I would like you to try this again. Pause the video for 5 minutes and work this one out. You need to think about how you could work out the gradient function of y equals 1 over x. So of course you start off with writing dy dx equals to limit h approach 0, 1 over x plus h minus 1 over x over h. Alright, what we need to do is bring the numerator to the same denominator, x plus h, which is x minus x plus h divided by h, and limit h approach 0 of x minus x plus h minus h, my fault, that should be minus over x plus h divided by h. Alright? Agree? So therefore I've got limit of h approaching 0 minus h over x plus h times 1 over h, which means we can eliminate the h here. So therefore limit of h approaching 0 is actually 1 of x plus h, which is when x equals to 0, I've got limit, don't need to write the limit anymore. When h approaches 0, what we have is minus 1 over x squared. So that is your gradient function of y equals to 1 over x using the process of differentiation by first principle. So I'm going to show you how to use the class pad as well. So if you could bring your class pad out, I will go through the class pad. You can follow the video. Alright, let's have a look at the class pad. First of all, we need to go to main and go to action, command, and define. What you're going to do is use your keyboard under ABC. Let's call it f of x equals to x squared. Click execute. So it is done. You know what fx is. Then go to keyboard under match to, which is limit. What you want is go back to your alphabets. You want h, h to approach 0, and here what I would put in is the different quotient. So under fraction, I'll put in back to my alphabet again, f of x, not g, f of x plus h minus f of x divided by h. And bingo, you've got the derivative, which is 2x. Sometimes it is not as useful using your class pad because you really have to type in everything. However, I need to show you so that you could use your class pad. Alright, I've shown you how to use the class pad. So that is the end of the lesson, and just reflecting on your learning. You should be able to define a limit and apply a limit to 0 to the difference quotient to find the gradient of a function by first principles. You should be able to generalize the gradient function or derivative using the first principle process, and finally link the concept of a derivative to small change.